This lesson is to show how to take a problem where you're given a variable to stand for one of the trig functions. So in this case, the variable x is what we'll use to represent tangent of theta. You're also given what quadrant theta is in, and then you're supposed to find an expression for cosecant of 2 theta in terms of this variable x. Now, the same problem could have just been, write an identity for cosecant of 2 theta in terms of tangent theta. But that actually is more complex of an exercise, and it simplifies it somewhat to just label tangent theta with some other variable and say, all right, it could be anything. You could say let y equal tangent theta or let p equal tangent theta. It's just, x is the most common variable that's used, and so they use x. So the first place to start is to say, okay, so tangent of anything is, the y over the x, if you will, or using SOHCAHTOA in a right triangle, it's the opposite over the adjacent. So putting myself in a right triangle, and since we're in quadrant 1, don't even have to think of as reference angle. It's just here's a representation of the reference angle with theta right there. I don't know if it's the bigger or the smaller acute angle. I don't have enough information, but just make a triangle like that. And then say, all right, so it's supposed to be x or x over 1 if I make a ratio out of it so that I have two values. So the opposite I'll call x, and the adjacent I'll call 1. So let me do that. So the opposite of theta, that's x, and the adjacent is 1. With Pythagorean theorem, 1 squared plus the other leg squared is the hypotenuse squared. Let me just call this c for a second. Or solving for that hypotenuse, it's the square root of 1 plus x squared. Well, that's great. I have this right triangle. I have SOHCAHTOA. I can immediately get sine and cosine. Just it's really, this opposite is the position of these sides as opposed to what they're being called for the purposes of this problem. So opposite is x, adjacent is 1, hypotenuse is square root of 1 plus x squared. And so we can get sine and cosine, for example. So let me just draw this on the other page. I'm running out of space. So here's theta, here's what we've got. And so, for example, we already started with tangent theta, opposite over adjacent, but we could get sine theta. And that's opposite over hypotenuse. Or we could get cosine theta. And that's adjacent over hypotenuse. And yes, I'm not rationalizing these, I'm just getting an expression for them. So what we're trying to get is the cosecant of 2 theta. Well, that's just 1 over the sine of 2 theta. And the identity, the double angle identity for sine, is that sine of 2 theta is 2 sine theta cosine theta. Well, I just figured out sine theta and cosine theta in terms of x. So this is going to be 1 over 2 sine theta cosine theta. And this is actually looking like something. So we've got just 1 on the top, but on the bottom we've got 2x. So we've got 1 on the top, and let me give myself just a hair more space. Got 1 on the top, and we've got 2x in the numerator on the bottom. And then square root of 1 plus x squared times square root of 1 plus x squared, that's just 1 plus x squared. wait a minute, 1 over a fraction is just the reciprocal of that fraction. So let's see, got some space over here. 1 over 2x over 1 plus x squared is 1 plus x squared over 2x.